Series and parallel circuits. Now, in series circuits, the components are arranged in a continuous run, so the same electrons flow through each component in turn. And this means that the current is the same through each component. However, since each electron passes through each component and transfers energy to each, the PD is shared between the components, but not necessarily equally. It depends upon the resistance of the individual components. In parallel circuits, the components are arranged in bypass routes, so the flow of electrons is diverted between routes. And this means that the current is shared between components, but not necessarily equally. This depends upon resistance. However, since each electron transfers energy to only one component, the PD for each component is equal to that for the cell. Now, if you've got several cells connected to form a battery, then the PD for the cells connected in series is the sum of all the cells. But if one of the cells is reversed, then the PD for that cell is subtracted from the total. Resistance in series and parallel circuits. Now, resistance for each component in series is summed or added up to give the total resistance for the circuit. So have a look at this series circuit. You've got 3 bulbs, so that's 3 resistors. Now, these 3 filament bulbs don't have exactly the same resistance, but the same current, 3 amps, flows through each. So calculate the PD for each bulb using the correct equation. Calculate the total resistance for the circuit, remember they're summed, and then calculate the PD provided by the cell. And check your answers here. Resistance in parallel. Now, these 3 bulbs don't have the same resistance either. So what's the PD across each bulb? Calculate the current flowing through each bulb, calculate the current for the whole circuit, and then try and work out which bulb is brightest and why. So use your correct equation. So pause the video and do all your calculations, and then you can check your answers using the answers here.